Assalamualaikum warahmatullahi wabarakatuh, and good morning everyone. Today me Nur Aiwaida binti Muhammad Khair with my group member Nurul Nadirah, Nur Syamim Amni, Nur Atirah and Nur Atira Natasha.
Today we would like to present about vanillin in a Madagascar vanilla bean.
Today's agenda will be divided into 4 sections, which are the introduction, methodology, analysis, and lastly conclusion with some additional info. Before we started, what is gas chromatography? Gas chromatography (GC) is an analytical technique used to separate the chemical component with the sample mixture and then detect them to determine the absence or presence or of how much is present, and now this play a very important role in the identification and quantification of ubiquitous pollutant in the environment. Gas chromatography (GC) is also used widely in applications involving food analysis. Typical applications pertain to the quantitative or qualitative analysis: food composition, natural product, food additive, flavor, and aroma components, a variety of transformation products and contaminants such as pesticides, fumigants, environment pollutants, natural toxins, veterinary drugs, and packaging materials. Next, vanillin. Vanillin is an organic compound with the molecular formula CH8HNO3. It is a phenolic aldehyde. Its functional groups include aldehyde, hydroxyl, and ether. It is a primary component of the extract of the vanilla bean. Synthetic vanillin is now used more often than the natural vanilla extract as the flavoring agent in food, beverage, and fermentation. Now, here are some facts about vanillin. First, as vanillin have the same function as vanilla, even with the similar name, people always think that vanillin is a vanilla, but it is not. Vanillin is naturally occurring chemical compound that we recognize as the primary aroma.
For methodology, here is the materials and chemicals that is used in this experiment. So for the first procedure is isolation of the volatiles. Starting with Madagascar vanilla beans were cut into pieces, frozen with liquid nitrogen, and then ground into a fine powder. There are 30 grams of the ground powder was extracted with the ethyl ether at room temperature for 1 minute and then filtered. The filtrate was tried over sodium sulfate and concentrate to about 10 ml by distilling off the solvent. Then the volatiles of the concentrate were distilled under reduced pressure at a temperature rise from room level to 80 degrees Celsius in 20 minutes and then maintained at 80 degrees Celsius for 10 minutes under 500 Pascal. And last, the resulting distill was tried over sodium sulfate and concentrate to approximately 50 mg. The next procedure is sensory evaluation. The first step is vanilla beans, MV red wool, and MV cuts, which were the same samples as used for GC, MS, and EDA, were cut into 1 cm pieces, frozen with liquid nitrogen, and then ground into a fine powder. The next step is 10 grams of each ground bean samples was directly put into a closed 30 ml sensory vial. The next procedure is reconstructed aroma. This procedure was divided into 2 categories. The first one is MV red whole and reconstituted MV red whole. Aroma test samples were evaluated by 11 panelists. And the second one is MV cuts and reconstituted MV cuts aroma test samples were evaluated by 8 panelists only. For the fourth procedure, which is evaluation attributes, there are 7 attributes of floral, dried fruit-like, resinous, hair-like, metallic, phenolic, and sweet were applied. These attributes had previously been selected by our laboratory as a suitable vocabulary for describing the aroma of vanilla beans that is commonly used for sensory evaluation. For the last procedure is evaluation condition, which the procedure before were used in this procedure, as the panel were instructed to sniff each sample and rate the intensity of the 7 attributes on a 7-point linear scale from 1 to 7, which are very strong. So the evaluation was conducted in a quiet room, kept at 23 degrees Celsius. Two booths were set up in the room, and each panelist was asked to perform the assessment in an individual booth to eliminate any influence from each other.
The first result, we're going to go through the result of odor quality. For the first odorant, which is acetic acid, it has a acidic and sour odor. For the 2-methyl butanoic acid and 3-methyl butanoic acid, they have a same odor, which is buttery and cheesy like. For the beta damascenoid, it has a resin-like and fruity odor. And for guaiacol, it has a medical and phenolic odor quality. For the 2-phenylethyl alcohol, it has a floral and rose-like odor. And for methyl guaiacol, it has medical and phenolic odor. Methyl cinnamate, it has a fruity and cinnamon-like odor. And for the wine nanolactone, it has a coconut-like and creamy odor. For the methyl cinnamide, it has a fruity and cinnamon-like odor. For the p-cresol, it has a fecal odor quality. And for the ethyl cinnamate, it has cinnamon-like fruity odor. And for Y-dicalcotone, it has peach-like and fruity odor. Eugenol, it has a clove-like spicy odor quality. And for phenylacetic acid, it has a buttery honey-like odor quality. And for the second last, which is vanillin, it has a sweet and vanilla-like odor quality. And for last one, 3-phenyl propanoic acid, it has a metallic and buttery odor quality. For the second result, we will go through to the FD factor. FD factor is divided to the two types, which is MV red hole and MV cat. For the first odorant, which is acetic acid, it has a 125 MV red hole. And for the MV cat, it has 5 cat. And for the 2-methyl butanoic acid and 3-methyl butanoic acid, they have a same MV red hole and MV cat, which is for the MV red hole, it has 125 cat, and for MV cat, it has 25. They both have 25 cat. For the beta damascenoid, we have 3125, and for the MV red hole, and for the MV cat, we have 15,625. For the guaiacol, for the MV red hole, it has 390,325, and it has 78,125 MV cat. For 2-phenylethyl phenylethyl alcohol, the MV rate hold is 125, and for the MV cut, it has a 5 cut. For 4-methyl guanylyl, it has a 25 MV rate hold and 125 MV cut. For the methyl cinnamate, it has 25 MV rate hold and 125 MV cut. For the Y-nonyloctane, it has 125 MV rate hold and 3125 for MV cut. For the methyl cinnamate, it has 125 for the MV rate hold, and for the MV cut, it has 125 too. For the p-cresol, it has 3125 MV rate hold, and for the MV cut, it gains 625. Ethyl cinnamate, it has 15,625 MV rate hold, and for the MV cut, it has
Hi, Assalamualaikum. My name is Nur Afiatasha with Managing Lady. Next, I will
For the
present about
Y-decaloctane,
discussion in
it
GC.
has 125 MV rate
These
hold,
results
and for the
enable
MV
us
cut,
to
it gains
characterize
1.
the aroma of the
For the
Madagascar vanilla red
eugenol,
wool as
it
dry
has
fruit like and
335
sweet,
MV rate hold,
while
and for the
Madagascar
MV
vanilla
cut, it
cuts
gains
was characterized as phenolic and
3,125
metallic.
cut.
Therefore, we confirm that
The
the dried
third last
fruit
of the
and sweet
odorant is
attribute
phenylacetic
were positive
acid.
factors for
Phenylacetic
the
acid
MV
has
red wool
125
aroma,
MV
whereas
rate
the
hold
phenolic
and
and metallic
625
attributes
MV
were
cut.
negative
For the
factors
vanillin,
for the MV
it gained
Next,
and
vanillin
for
had
the
the
MV
highest
rate
flavor
hold,
dilution
it has
factors and was considered to be the most
for the
characteristic
vanillin,
odor
we
active
have
compound in MV red hold.
MV rate
This
hold
being
will gain
followed by guayacol and ethyl cinnamate. Both
953,000
vanillin
and
and guayacol
125
showed the
MV
highest
rate
flavor
hold,
dilution factors
and it
and
will
were
gain
found to be the most characteristic odor active
78,125
compounds in
MV
MV
cut.
cuts.
And the last one,
This
3-phenyl
result
propanoic acid.
indicates
It
that the
will,
most
it
odor
will
active
gain
compounds such as vanillin,
635 MV
guayacol,
rate hold,
ethyl
and
cinnamate,
for the
and
MV
damascenone
cut, it
were
will
common to
gain
red wool and cut
625.
beans. Based on their odor qualities, vanillin and guayacol respectively contribute to the sweet and phenolic attributes by the sensory evaluation, and both ethyl cinnamate and damascenone contribute to the resinous and dried fruit-like attributes. Next, although vanillin, acetic acid, and guayacol were abundantly present in both samples, vanillin in MV cuts was 5 times and acetic acid was 4 times lower than in MV red hold, while guayacol in MV cuts was 1.3 times higher than in MV red holds. And the last one, the concentration ratio of vanillin to guayacol was 143.6 in MV red holds, and this being 7 times higher than in MV cuts, which is 20.69.
Hi, I am Nurshimim Amni binti Rasmayadi, the representative from our group to conclude our findings of this study. By the end of this study, we can say that gas chromatography is a method that is very useful in analyzing vanillin in Madagascar vanilla bean. After a study made on vanilla bean, we found that vanillin was categorized as the most odor-active compound with flavor dilution equal to or more than 3,125. Vanillin was by far the most abundant odorant with the highest concentration of 10.9 gram per kilogram in Madagascar vanilla MV red hold. Although vanillin along with acetic acid and guayacol were abundantly present in both MV red hold and MV cut samples, vanillin in MV cut was 5 times lower than that in MV red hold. You can see that different grades of Madagascar vanilla beans carry different amount of content in reconstituted aroma. A study was made to investigate the effect of concentration ratio of vanillin and guayacol on the aroma of Madagascar vanilla beans. And from the result obtained, we conclude that the concentration ratio of vanillin in vanilla bean could be used as an index of the quality of Madagascar vanilla.